Hi cadets, Dr. Boyce here. I just wanted to go over a few more things that we either didn't cover or I just wanted to cover in more detail related to Lesson 4. So the first is CPRESS. So CPRESS is a mnemonic that you can use to help you remember the threat stability. So C stands for compounds, P stands for placebo, R stands for replicating, E stands for experimenter expectancy, S stands for social desirability, and S stands for sampling bias. So just something to help you jog your memory as you're studying for the test. So, key stats. Alright, so first we have our central tendency. This is your mean, which is your average, your median, which is your middle, and your mode, which is your most frequent. Then we have, and those all fall under central tendency. Then we have variability. So this is where the standard deviation comes into play. Standard deviation is how much your data set scores vary from your mean. The reason why this matters is sometimes you will have outlying data points which might really pull your mean toward one direction or the other. You could also have two distributions that are very similar, but the level of the peak of those distributions or the variability is very different. And we'll talk about this in a couple slides. Then finally you have correlation. So correlation, remember, you have the direction of the correlation. So it is either positive, where you have your two variables going in the same direction, or negative, where you have your two variables going in opposite directions. And it can be thought of as either weak or strong. Weak meaning closer to 0, and strong meaning closer to 1 or -1, depending on if your relationship is positive or negative. So again, mean, median, and mode. And this is what I was talking about in terms of variability. So here these two distributions have the same mean, but one has a lot more variability, and one has a lot less. So in the case of A, the scores are bunched together. So there's less variability than in B, where there's more variability or more spread around the distribution. Correlations. So, I don't know if I mentioned this in class, but the key with the correlation is the correlation coefficient, which is represented as R. Correlations represent the relationship between two variables, and they range from -1 to +1. So on this side we have a -1 relationship, and on this side we have a +1 relationship. But one of the things I wanted to show you is that, look, you can have strong relationships on both the negative side and the positive side. So how do I look at this, Dr. Boyce? Well, the first thing you want to do is you want to take the absolute value of the correlation of interest, right? So if you have a 0.25 correlation or a -0.25, you'll be able to tell, okay, that's a weaker correlation because it's closer to 0 than, say, a 0.50. Then you want to look at the sign. And you want to figure out, okay, is it a negative correlation? Is it a positive correlation? And remember, with positive correlations, your two variables go in the same direction. Either positive, positive, or negative, negative. With a negative correlation, your variables go in the opposite directions. And I believe the next slide will cover that. Sorry. Yes. So, for a positive correlation, as one variable increases, the other one does as well. Also, as one variable decreases, the other one does as well. With a negative correlation, as one variable increases, the other decreases. Now remember, correlation does not equal causation, and we need to be able to have empirical testing through cause and effect relationships to be able to determine, if one variable causes another. Remember, this is the whole concept of independent variables versus dependent variables, and trying to create a hypothesis, going back to optic, about your question of interest. So, when we're talking about hypotheses, you can either have a null hypothesis, which means there's no difference or no relationship, but oftentimes we have an alternative hypothesis or a research hypothesis that says there is a difference or relationship between our two groups. And the way that we determine this is through the p-value. And the way that you can remember it is, if the p-value is less than or equal to 0.05, then the data that we have supports our hypothesis. This is also known as rejecting the null hypothesis. If the p-value is greater than 0.05, then the data does not support our hypothesis, or we fail to reject the null. And remember that this is basically trying to determine if your results are happening according to chance. So just as a recap, remember central tendency, variability, and correlation. Central tendency, mean, median, and mode. Variability, if you have large variability, you're going to have a large standard deviation. If you have small variability, you're going to have a small standard deviation. And it's all about the spread of your data points around the mean. Correlation, remember that you have to look at both the direction of your correlation. Is it positive or negative? And the strength. So how close is it to 0? Or vice versa, how close is it to -1 or 1? And remember that we use inferential statistics to test whether, when we have two hypotheses, do we have statistical significance, and we do that according to the p-value. P-values less than or equal to 0.05 mean that the data supports our alternative hypothesis, and we can reject the null. If it's greater than 0.05, then we fail to reject the null hypothesis. Alright, so that's just a quick recap of some content that we covered in lesson 4, and I will see you guys.